When a polynomial is in factored form, it's very easy to find the zeros or the x-intercepts of the polynomial. Remember, zeros and x-intercepts are basically the same thing. We find them the exact same way. So this polynomial, both of these down here have been factored. Every piece is being multiplied together. The first thing they ask me to do is state the degree of this. Well, like we did in a previous video, if you watched that one, I'd have to imagine what would my highest exponent be if I did multiply this all out. Without doing all the work, I can see fairly easily that eventually in this problem I'd be doing x times x times x, which would get me x to the third power. So my degree is 3. My highest exponent would be 3 if I multiplied all of this together. Then to find the zeros, it's simply a matter of the same thing we did when we were solving quadratics. We'd put each factor equal to 0 and solve. So 3 is one of my zeros. 2 is going to be another 0. And most people realize real quickly too that for a lot of these problems they can just change the sign of the factor and get my 3 zeros. So there are my 3 zeros or my 3 x-intercepts of this polynomial. Notice I had 3 zeros and my degree was 3. How curious. If we try the next one, this time I want to state my degree first again. I've got 1, 2, 3, 4 x's. So my degree would be x to the, or 4, because I'd have x to the 4th power if I did multiply all of this out. And then just like last time, I can go through and get my zeros by setting each factor equal to 0. I'd have -4. I'd have 1, and remember we can just change the signs for a lot of these easy ones. And then some people get thrown off by this first x. Well, like we would do on any of these other ones that we were setting equal to 0, just set x equal to 0, so there's your solution. So notice this time my degree was 4 and I had 4 solutions, which was the same as the degree. So to answer this question down here, the number of zeros, the number of x-intercepts you have, is always the same as the degree. Now, that is true, but sometimes we have to take into account imaginary solutions, which wouldn't show up as x-intercepts, and sometimes we have to take into account repeated solutions. So let's take a look at repeated solutions real quick. Sometimes repeated solutions are called multiplicities, but they mean the same thing, and to find them, we'll simply look at the powers of the factors that we're working with. So once again, both of these polynomials are already factored for us. My degree of each one this time is going to be 4. I can imagine if I were to multiply this out, I'd have an x squared eventually. Not that we're allowed to distribute exponents, but eventually I'd have an x squared times another x squared, and x squared times x squared would get you x to the 4th power. So hopefully without going into too much depth on that, we can see that they're both degree 4. That's x to the 1st power. And then another x to the 3rd power multiplied together would get you x to the 4th, which is degree 4. Anyway, if that didn't confuse you. To find my factors then, once again I put each factor equal to 0. So my factors are -1 and +2. But we just said that we should have an equal number of solutions, x-intercepts, as we do the degree. Well, that's where the multiplicity comes into play. So this is a solution of -1, but what we would say is it has a multiplicity of 2, meaning we have to count it twice. It's a repeat or a double solution. Same thing goes on that 2. It has a power of 2 on that factor. So we'd say the solution is 2, but with a multiplicity of 2, meaning it counts twice. It's a double solution. Same goes for these odd powers. Once again, -1 and 2 are my 2 solutions. However, the powers will tell us how many times to count those. This -1 just gets counted once, so we don't need to say a multiplicity of 1. I'll just assume that's what you mean if you list it one time. But the 2 has a multiplicity of 3. We'd count it 3 times because it has a power of 3. And then without graphing, with just kind of taking my word for these, or if you want to graph them, the graph will behave a special way around repeated solutions, specifically if they're even or odd. Anytime you have an even repeated solution, that graph is going to bounce off the x-axis. It'll just come and touch the x-axis and bounce right back up. So for example, if you did graph this first one that had zeros at -1, and then zeros at 2 that were both double, your graph is going to come and bounce off the surface and kind of bounce back up. So they'll always bounce or just touch. Versus an odd power, which once again, you'd have to graph this for yourself if you want to double check me on it. Odd powers will always just pass right on through. They won't do anything special. I'm not saying those are the actual graphs of this polynomial. I'm just saying odd powers will pass right through the x-axis. They'll just cross right over. But even powers will always bounce on the x-axis.